Next we will see what is forward and backward pass in network. See, forward pass always determines the yearly start or yearly finish time of various activities in a construction project. And if more than one converging activity is there in a node, you have to consider the maximum time. And forward pass, always you move from left to right. Okay. So here, for example, there are three activities B, C and D. See, as you see here, the earliest start, this box denotes the earliest start, this number denotes the earliest finish, and in the forward pass you are going to calculate the earliest times, right? Now you see, when you take activity E, okay, so this is a node, this rectangle is a node. So in this node, three activities are converging or coming inside. So in the forward pass, now the earliest finish time of activity B is 6 and activity C is 7 and activity D is 9. Now when we move to the next activity E, you have to take the maximum of these three values, 6, 7, 9, which is the maximum, 9 is the maximum. So 9 you take it as the earliest start time of activity E. That is the meaning of forward pass. We'll stop here. Yeah. Now we will see about backward pass. See, backward pass determines the late start or late finish time of various activities involved in a construction project. And if there is more than one diverging activity from a node, consider the minimum time. Okay, and backward pass means you are moving from right to left, right to left. Okay, so here in this example, whatever you are seeing here, see here activity B, C, D. Okay, three activities are coming back inside this node A, activity A. Okay, and see, diverging means from this node, right? From node or activity A, from this node, three activities are diverging. Okay, now coming back. Okay, so this is the latest start time or activity B, and this is the 5 is the latest start time of activity C, and 3 is the latest start time of activity D. Now when we come back in the backward pass, we have to take the minimum value. So which is minimum? Out of 6, 5 and 3, 3 is the minimum value. So we are taking 3 as the latest finish time of activity A. Okay, so this is the meaning of backward pass. I hope you understood. Thank you. Yeah, next we will see simple or basic rules for drawing a network diagram. See, the first rule is network should have only one initial node. See here, there is a node here which is represented by a rectangle, and this is the first node and it is the initial node also. Okay, and the initial node will have only outgoing arrows. So from this node there is an outgoing arrow to this another node B, and another outgoing arrow from A to C. There is a meaning. An initial node will have only outgoing arrows. So again, next point, network can have only one final node. So if you see in this same network diagram, so here you see the H, you can see the activity H represented in this particular node. So there is only one final node, and final node will have only incoming arrows. Okay, so I'll stop here. Now I would like to explain you the first 2 points based on the second network diagram. See, the first point is a network should have only one initial node. So here we forgot about the start. There are two initial nodes, A and B, starting at the same time. Okay, two activities A and B, which you are representing in two separate nodes. In that case, we have to add one more node to the left hand side of these two nodes and mention it as start, and you can connect these two nodes from this start node. Similarly, network can have only one final node. So here you see finish is the final node. In case if this final node is not there in the network, two nodes will be there which represent two activities E and F. Okay. Now if you leave it without connecting this final node, this condition will not be satisfied, right? So you have to if you have two final nodes separately, you have to connect these two nodes by adding one more node like finish, and you have to connect it and finish it. Okay, I'll stop here. Now I will explain you the last 2 points, right? See, the third point is network should be drafted such that all activities are completed to reach the end objective. While drawing the network diagram, you should not forget or leave any activity behind, and in that case you cannot be able to find the completion time, actual completion time of the project. Similarly, the last point, network logic should always be maintained. That means, see, for C, activity C, A is the preceding activity as well as B is also the preceding activity. You should not leave B and then show only A. So in that case also there may be some mistakes and you will not be able to find the correct or exact completion time of the project. Similarly, for activity D, also B is the preceding activity. So like that, the network logic should be maintained in this particular type of network. Thank you. I hope you understood. We will continue again. Yes, moving on to the next topic, what is called as critical path method, right? I'll just tell you about this method, okay, briefly. It is just a project management technique used to estimate the completion time of a construction project along its critical path. As we know, critical path is a path which connects the critical activities, right? And CPM is always based on activities, and it is also deterministic in approach. It means since it connects the critical activities, it cannot delay the critical activity. Any delay in the critical activity will delay the completion time of the project. So it is determined to finish the critical activities. Okay, so we call it as deterministic in approach, and the uncertainties and risks are usually neglected in this type of approach because we assume that all the activities will be completed as per the schedule. or on time. It will be completed on time. And the risks in that particular projects also we consider as minimum, and it can be neglected. I stop here. Hope you understood the concept. Thank you. See, next we will see the different types of activity times, right? Okay, so here when we see the different types, we have earliest start time, earliest finish time, latest start time, and latest finish time. When we say the earliest start time, it is the time in a schedule, that is project schedule, at which any activity can start, assuming that its predecessors have been completed or complete. Okay, and it is denoted by EST, earliest finish time. It is the time in a schedule at which an activity can finish in a project, and it has a small formula, EFT equal to EST, that is earliest start time plus duration. Moving to the next type of activity time, we call it as latest or late start time. Okay, it is the latest time in a project schedule at which an activity can start without delaying the project completion or without delaying the duration of the particular project, and it is denoted by LST, that is equal to LFT, latest finish time minus activity duration. Similarly, latest finish time is the time in a project schedule in which an activity can finish without delaying the project completion. Okay, I hope you understood the different types of activity times. I will stop here.